Hello students, welcome to In 5 Minutes. We'll start today with Type 1, Sum based on standard definition of Laplace transform. My first sum is find Laplace transform of f of t for sin 2t 0 to pi, and when t is greater than pi it is 0. Students, we can't use your standard formulas because your function is not defined from 0 to infinity. It has splitted from 0 to pi and pi to infinity. Now I say here from 0 to pi my function is sin 2t. So for 0 to pi it is sin 2t, and for pi to infinity my function is 0. So let's start with solution. Laplace of f of t, that is nothing but 0 to infinity e raised to minus st f of t dt. Now as we know, for 0 to pi my function is e raised to minus st sin 2t plus, and for pi to infinity e raised to minus st 0 dt. So that comes, the second term is 0 and the first changes to e raised to minus st divided by s square plus 4 minus s sin 2t minus 2 cos 2t, where my upper limit is pi and lower limit is 0. So when you put upper limit, that becomes e raised to minus s pi divided by s square plus 4. When you put pi here, that becomes 0, and cos 2 pi, that becomes 1, which comes a value of minus 2. When you put a lower limit, it comes e raised to 0, that is 1, divided by s square plus 4. And you put 0, sin 0 is 0, cos 0 is 1. So again you get a minus 2. So I can say I got minus 2 e raised to minus s pi, minus and minus becomes plus 2, whole divided by s square plus 4. And finally my answer changes to, taking a 2 common, 1 minus e raised to minus s pi divided by s square plus 4. So that's my sum completed. We'll do one more sum on this. So my second sum is find Laplace transform of f of t, that is equal to t minus a the whole cube, valid for t greater than a. When t is less than a, my function is 0. So we need to find Laplace again. So first I define range. So we can understand easily that we have a range of 0 to infinity. Let us consider a. For t greater than a, my function is t minus a the whole cube, and for t less than a, your function is 0. So I say that Laplace of f of t, that is nothing but 0 to infinity e raised to minus st into f of t dt. So which goes with, let's put function here. So for 0 to a e raised to minus st, my function for 0 to a is 0, and that into dt, plus for a to infinity e raised to minus st, my function is t minus a the whole cube into dt. So by solving this, I can say my first term becomes 0 and second terms work with respect to u into v, where this is u and this is v. So I start with u into v, that comes t minus a the whole cube e raised to minus st divided by minus s, minus 3 into t minus a the whole square e raised to minus st divided by s square plus 6 into t minus a e raised to minus st divided by minus s cube, and then minus the differentiation of t minus a into 6 will be 6 e raised to minus st divided by s raised to 4, where your upper limit is infinity, lower limit is a. When you put upper limit as infinity, e raised to minus infinity, e raised to minus infinity, the whole term becomes 0. And when you put a lower term a minus a minus a minus a, that becomes 0, and only get a last term, that is minus 6 divided by s raised to 4 e raised to minus as. So which gives me a final answer of minus and minus becomes plus 6 divided by s raised to 4 e raised to minus as. That's my final answer. Thank you for watching in 5 minutes.